Okie dokie. So pause and copy all this for me, please. Pause and copy. Pause and copy. Okay. So you may recall doing limits of this form. Okay, depending on your teacher, maybe you just say, oh, ignore this, cancel, cancel, and you're done. Over here is not so clear. Um, Technically possible to say that this and this are dominant and to go from there, but L'Hopital's rule is going to give us a perhaps more systematic way to deal with limits like this, and they will appear, maybe not quite so messy, but certainly with the e to the x, they're going to appear in 7.4 when we do certain types of integrals. Anywho, so pause and copy this theorem down, which is L'Hopital's rule. Pause and copy. Okay, so the main thing, there's a lot of words there, but the main thing is this equation. Okay, so what is it saying? Well, it's saying basically as long as this limit makes sense here, you can take your original, replace it with this guy, and hopefully this guy will be easier. Okay, so indeterminate form, infinity over infinity means f is approaching infinity and g is approaching infinity. Okay, so you have to make sure that your original limit is either of this form here or 0 over 0. And what else should I say? The number a here a can be plus or minus infinity. It doesn't have to be a real number. Okay, so again, this is the main thing. We're going to use this equation to take our complicated limit and replace it with something hopefully better. Okay, let's look at an example. So, let me just pause and quickly copy that. See if I can get L'Hopital's rule in the picture too. Okay, so we're going to use this formula here. Now I'm going to double check, right, that this is indeed, the numerator is going to infinity, and the denominator is also going to infinity as x goes to infinity. So you could say it's, of that form. So we can use L'Hopital's rule. So sometimes you'll put an equal sign with an h on top to indicate you're using L'Hopital's rule. So we can replace that with the derivative of x over the derivative of e to the x. I've already written x goes to infinity here, so you don't have to write it here if you don't want to. So what do I get here? I get limit of 1 over e to the x. Now, why is this good? Well, it's good because this over here was a confusing situation. The numerator is going to infinity, and the denominator is going to infinity, and they are kind of working against each other, right? And I don't know who wins, but over here, it's clear who wins, right? The numerator is just 1, and the denominator is infinity, right? Or is going to infinity. Okay, so there's no confusion here. I can just say this is 0. Okay, I can think of it as 1 being divided by an increasingly large number. What is this process tending to? Well, it's tending to 0. Okie doke. If you flip the fraction, you get something else happening, right? You get plus infinity there. Okay, pause and copy that. I want to emphasize that you always have to check that you have something of the right form. Okay, it has to be infinity over infinity or 0 over 0. Otherwise, you cannot use L'Hopital's rule. Now this one, you may jump in and use L'Hopital's rule, but that would not be correct. Because this one, the numerator is approaching minus infinity, and the denominator is approaching 0. And how do I know that I have a 0 here? Well, I have memorized the graph of e to the x. It looks something like this. Okay, so when you're going to minus infinity, you're going that way. Now, what else? Well, I know I can't use L'Hopital's rule. So what can I do? Well, I should first notice that when I approach 0 up here, I'm approaching it, it's actually 0 plus. Okay, I'm approaching 0 through positive numbers. Okay, so when I look at this fraction, it's actually not, it's not confusing. It's a determinant form. Okay, the numerator and the denominator are working together. They're both pushing in the same direction. The minus infinity on top is making the fraction large and negative, and the 0 plus on the bottom is making the fraction large. So they work together, which is different than what I had up here, where the infinities were working against each other. Okay, well, what's next? Let's try one as an exercise. Okay, pause, copy, try. Pause, copy, try. So what do I get? I do L'Hopital's rule because this is infinity over infinity. And I get 1 over 2x, which is 0. Because this is 1 over infinity. Okay, copy that. And I'll do a more complicated example. Oh boy. Limit x goes to 1 plus sine pi x over root x minus 1. Okay, so what is the problem here? Do I have a problem? Well, sine of, if I plug in 1 here, I get sine pi, which is 0. And on the bottom, I also get 0, right? So this is 0 over 0. Now I can use L'Hopital's rule. Okay, it does apply in this case where you have a one-sided limit, thankfully. So I do so. I do a L'Hopital's rule here, putting the H to indicate that. And what do I get? I get cos pi x times pi for my chain rule. On the bottom, I get half x minus 1 to the negative a half. And what does that equal? Moving things around, I get 2 x minus 1 to the half, maybe 2 pi. Sorry, 2 pi in front. And then I get cos pi x bracket, why not? X goes to 1 just for emphasis. Okay, now my fraction has disappeared, right? So this confusion has been resolved. Cos of 0 is 1. So I can just plug in the 1 plus and get 0. Very happy. I'm very happy about that. Yeah.